trying to measure the level inside a pressurized vessel can get very interesting. But if you do stick to first principles and basics, it's actually quite easy. I'd like to show you how to do this. I'm going to use crazy hypothetical values just for the explanation. I want you to imagine that I have a pressurized vessel, and in the blue we're going to have the force of the liquid pushing down. As I say, crazy values, I'm just going to go and put in 1 bar. In other words, 100 kilopascals. I'm going to have exactly the same on the right hand side, 1 bar. Now let's go and say that on the left hand side, the yellow is the pressurized area, and possibly that's going to sit at 5 bar, and 30 seconds later that might sit at 10 bar. Now can you imagine the pressure that you're trying to measure at that point? On the left hand side, you're going to have the 5 bar plus the 1 bar, which is equal to 6 bar. And 30 seconds later on the right hand side, you're going to have the 10 bar plus the 1 bar, which is equal to 11 bar. So your pressure transmitter is going to be all over the place, and it's not going to give you a reading which you and I can go and use at all. Now the solution to this is to not use a normal pressure transmitter, but to rather use a differential pressure transmitter. And this is what I have gone and added to the sketch. You're going to put your high pressure side of the pressure transmitter at the lowest point, and the low pressure side will be connected to the top of the vessel. Exactly the same on the right hand side. We're going to have the high pressure connection and the low pressure connection. Now what you can see is that we are going to have the pressure that we can measure at the high pressure side, and I'd just like to make these sketches slightly smaller so that I have space to write. And now the system should be able to calculate the differential pressure. At that point at the bottom left, we are going to have a pressure of 5 plus 1. And what we want to do is we want to subtract that from the pressure that is pushing down from the top, which is going to be 5, which is going to give me 6 minus 5, which is equal to 1, which is the pressure that we are going to have in the liquid. Exactly the same on the right hand side. If I go and look at the pressure that we do see over there, then we can say that we're going to have the 10 plus 1 minus what is getting put down on the other side, and that's going to be 10, which gives us 11 minus 10, which gives us an answer of 1, which is the liquid that we're trying to measure. So in this instance, it's always best to go and use a differential pressure transmitter to do this type of measurement. Again, it's important that your density must stay constant at all times. And that is it. Nice, quick, and easy. That's how you're going to measure the level inside a pressurized vessel by means of hydrostatic measurement.